So could we talk about Fermat's library?
Yeah, absolutely.
What is it? What's the main goal? What's the dream?
It is a platform for annotating papers in its essence, right? And so academic papers can be one of the densest forms of content out there and generally pretty hard to understand at times. And the idea is that you can make them more accessible and easier to understand by adding these rich annotations to the side, right? And so we can just imagine a PDF view on your browser, and then you have annotations on each side, and then when you click on them, a sidebar expands, and then you have annotations that support LaTeX and Markdown. And so the idea is that you can, say, explain a tougher part of a paper where there's a step that is not completely obvious, or you can add more context to it. And then over time, papers can become easier and easier to understand and can evolve in a way. But it really came from myself, Luís, and two other friends. We've had this long-running habit of kind of running a journal club amongst us. We come from different backgrounds, right? I studied CS, Luís studied physics, and so we'd read papers and present them to each other, and then we try to bring some of that online, and that's when we decided to build Fermat's library. Then over time, it kind of grew into something with a broader goal, and really what we're trying to do is trying to help move science in the right direction. That's really the ultimate goal, and where we want to take it now.
So there's a lot to be said. So first of all, for people who haven't seen it, the interface is exceptionally well done. That's like execution is really important here.
Absolutely.
The other things just to mention for a large number of people, apparently, which is new to me, don't know what LaTeX is. So it's spelled like latex, so be careful Googling it if you haven't before. It's, sorry, I don't even know the correct terminology.
Typesetting language?
It's a typesetting language where you're basically writing a program that then generates something that looks, from a typography perspective, beautiful.
Absolutely.
And so a lot of academics use it to write papers. I think there's like a bunch of communities that use it to write papers. I would say it's mathematics, physics, computer science.
Yeah, that's it.
That's the main.
Because I'm collaborating currently on a paper with two neuroscientists from Stanford.
And they don't know that.
So I'm using Microsoft Word and Mendeley and like all of those kinds of things, and I'm being very zen like about the whole process. But it's fascinating. It's a little heartbreaking actually, because it's funny to say, but and we'll talk about open science. Actually, the bigger mission behind Fermat's library is like really opening up the world of science to everybody. Is these silly two facts of like one community uses LaTeX and another uses Word is actually a barrier between them. That's like, it's like boring and practical in a sense, but it makes it very difficult to collaborate.
Just on that, like I think that if there are some people that should have received like a Nobel Prize but will never get it, and I think one of those is like Donald Knuth because of tech and LaTeX, because it had a huge impact in terms of like just making it easier for researchers to put their content out there, like making it uniform as much as possible.
Oh, you mean like a Nobel Peace Prize?
Maybe a Nobel Peace Prize. Maybe a Nobel Peace Prize. I think so.
I mean, he at a very young age got the Turing Award for his work in algorithms and so on. So like an incredibly, like when I think it might be even the 60s, but I think it's the 70s. So when he was really young. And then he went on to do like incredible work with his book and with tech that people don't know.
And going back just on the reason why we ended up, because I think this is interesting, the reason why we ended up using the name Fermat's library, this was because of Fermat's last theorem. And Fermat's last theorem is actually a funny story. So Pierre de Fermat, he was like a lawyer. And he wrote like on a book that he had a solution to Fermat's last theorem, which but that didn't fit the margin of that book. And so Fermat's last theorem basically states that there's no solution. If you have integers a, b, and c, there's no solution to a to the power of n plus b to the power of n equals to c to the power of n if n is bigger than 2. So there's no solutions. And he said that, and that problem remained open for almost 300 years, I believe. And a lot of the most famous mathematicians tried to tackle that problem. No one was able to figure that out until Andrew Wiles, I think was in the 90s, was able to publish the solution, which was, I believe, almost 300 pages long. And so it's kind of an anecdote that, there's a lot of knowledge and insights that can be trapped in the margins, and there's a lot of potential energy that you can release if you actually spend some time trying to digest that. And that was the origin story for the name.
Yes, you can share the contents of the margins with the world.
Exactly.
That could inspire a solution or a communication that then leads to a solution.
But if you think about papers, like papers are, as João was saying, probably one of the densest pieces of text that any human can read. And you have these researchers, like some of the brightest minds in these fields, working on like new discoveries and publishing these work on journals that are imposing them restrictions in terms of the number of pages that they can have to explain a new scientific breakthrough. And so at the end of the day, papers are not optimized for clarity and for a proper explanation of that content because there are so many restrictions. So there's, as I mentioned, there's a lot of potential energy that can be freed if you actually try to digest a lot of the contents of papers.
Can you explain some of the other things? So margins, librarian, journal club.
So journal club is what a lot of people know us for, where every week we release an annotated paper in all sorts of different fields, but physics, CS, math. Margins is kind of the same software that we use to run the journal club and to host the annotations, but we've made that available for free to anybody that wants to use it. And so folks use it at universities and for running journal clubs, and so we've just made that freely available. And then Librarian is a browser extension that we developed that is sort of an overlay on top of Archive. So it's about bringing some of the same functionality around comments, plus adding some extra niceties to Archive, like being able to very easily extract the references of a paper that you're looking at, or being able to extract the BibTeX in order to cite that paper yourself. So it's an overlay on top of Archive.
The idea is that you can have that commenting interface without having to leave Archive.
It's kind of incredible. I didn't know about it. And once I've learned of it, it's like, holy shit. Why isn't it more popular, given how popular Archive is? Like, everybody should be using it. Archive sucks in terms of its interface. Or let me rephrase that. It's limited in terms of its interface.
Archive is a pretty incredible project, right? And it is, in a way, the growth has been completely linear over time. If you look at like number of papers published on Archive, it's pretty much a straight line for the past 20 years. Mm-hmm. Especially for like if you're coming from a startup background and then you were trying to do Archive, you'd probably try like all sorts of growth hacks and like try to then maybe like have paid features and things like that, and that would kind of maybe ruin it. And so there's a subtle balance there, and I don't know what aspects you can change about it. And
for some tools in science, it just takes time for them to grow. Archive is just turned 30, I believe.
Yeah.
And for people that don't know, Archive is this kind of online repository where people put preprints, which are versions of the papers before they actually make it to journals.
ARXIV,
exactly,
for people who don't know, and it's actually a really vibrant place to publish your papers in the aforementioned communities of mathematics, physics, and computer science.
It started with mathematics and physics, and then over the last 30 years it evolved, and now actually computer science now it's a more popular category than physics and math on Archive.
And there's also, which I don't know very much about, like a biology medical version of that, is the
bioarchive. Bioarchive.
It's more recent.
It's interesting because if you look at like these platforms for preprints, they actually play a super important role, because for instance, if you look at a category like math, for some papers in math, it might take close to 3 years after you click upload paper on the journal website and the paper gets published on the website of the journal. So this is literally the longest upload period on the internet. And during those 3 years, like it's that content is just locked, and so that's why it's so important for people to have websites like Archive, so that you can share that before it goes to the journal with the rest of the world. There was actually on Archive that Perelman published the 3 papers that led to the proof of the Poincare conjecture, and then you have other fields like machine learning, for instance, where the field is evolving at such a high rate that people don't even wait before the papers go to journals before they start working on top of those papers. So they publish them on Archive, then other people see them, they start working on that. And Archive did a really good job at like building that core platform to host papers, but I think there's a really, really big opportunity in building more features on top of that platform, apart from just hosting papers. So collaboration, annotations, and like having other things apart from papers, like code and other things. Because, for instance, in the field like machine learning, there's a really big, as I mentioned, people start working on top of preprints, and they are assuming that preprint is correct, but you really need a way, for instance, to it's not peer review, but distinguish what is good work from bad work on Archive. How do you do that? So like a commenting interface like Librarian, it's useful for that, so that you can distinguish that in a field that is growing so fast as machine learning. And then you have platforms that focus, for instance, on just biology. BioArchive is a good example. BioArchive is also super interesting because there's actually an interesting experiment that was run in the 60s. So in the 60s, the NIH supported this experiment called the Information Exchange Group, which at the time was a way for researchers to share biology preprints via mail or using libraries. And that project in the 1960s got canceled 6 years after it started. And it was due to intense pressure from the journals to kill that project, because they were fearing a competition from the preprints for the journal industry. Crick was one of the famous scientists that opposed to the Information Exchange Group. And it's interesting because right now, if you analyze the number of biology papers that appear first as preprints, it's only 2% of the papers. And this was almost 50 years after that first experiment. So you can see like that pressure from the journals to cancel that initial version of a preprint repo had a tremendous impact on the number of papers that are showing up in biology as preprints. So it delayed a lot that revolution. And but now platforms like BioArchive are doing that work, but there's still a lot of room for growth there. And I think it's super important because those are the papers that are open, that everyone can read.
Okay, but if we just look at the entire process of science as a big system, can we just talk about how it can be revolutionized? So you have an idea, depending on the field, you want to make that idea concrete, you want to run a few experiments in computer science, there might be some code, there'd be a data set for, some of the more sort of biology, psychology, you might be collecting the data set. That's called, a study, right? So that's part of that. That's part of the methodology. And so you are putting all of that into paper form, and then you have some results, and then you submit that to a place for review through the peer review process. And there's a process where, how would you summarize the peer review process? But it's really just like a handful of people look over your paper and comment, and based on that decide whether your paper is good or not. So there's a whole broken nature to it. Mm-hmm. At the same time, I love the peer review process when I buy stuff on Amazon, for the commenting system, whatever that is. So, okay, so there's a bunch of possibilities for revolutions there. And then there's the other side, which is the collaborative aspect of the science, which is people annotating, people commenting, sort of the low effort collaboration, which is a comment, Sometimes, as you've talked about, a comment can change everything, but or a higher effort collaboration, like more like maybe annotations or even like contributing to the paper. You can think of like collaborative updating of the paper over time. So there's all these possibilities for doing things better than they've been done. Can we talk about some ideas in this space? Some ideas that you're working on, some ideas that you are not yet working on, but should be revolutionized? Because it does seem that archive and like open review, for example, are like the Craigslist of science. Yeah, okay, I'm very grateful that we have it, but it just feels like it's like 10 to 20 years. Like, it doesn't feel like that's a feature. The simplicity of it is a feature. It feels like it's a bug. But then again, the pushback there is Wikipedia has the same kind of simplicity to it, and it seems to work exceptionally well in the crowdsourcing aspect of it. So, sorry, that's a bunch of stuff thrown on the table. Let's just pick random things that we can talk about.
Wikipedia, for me, it's the cosmological constant of the internet. It's I think we are lucky to live in the parallel universe where Wikipedia exists.
Yes.
Because if someone had pitched me Wikipedia, like a publicly edited encyclopedia, like a couple of years ago, like it would be, I don't know how many people would have said that would have survived.
I mean, it makes almost no sense. It's like having a Google Doc that everybody on the internet can edit, and like that will be like the most reliable source for knowledge.
On I don't know how many, but hundreds of thousands of topics.
Yeah. It's insane.
It's insane. And then you have users, like there's a single user that edited 1/3 of the articles on Wikipedia. So you have these really, really big power users that are a substantial part of like what makes Wikipedia successful. And so like no one would have ever imagined that that could happen. And so that's one thing. I completely agree with what you just said. I also
Sorry to interrupt briefly. Maybe let's inject that into the discussion of everything else. I also believe, I've seen that with Stack Overflow, that one individual or a small collection of individuals contribute or revolutionize most of the community. Like if you create a really powerful system for archive or like open review and made it really easy and compelling and exciting for one person who's like a 10x contributor to do their thing, that's going to change everything. It seems like that was the mechanism that changed everything for Wikipedia, and that's the mechanism that changed everything for Stack Overflow. Is gamifying or making it exciting or just making it fun or pleasant or fulfilling in some way for those people who are insane enough to like answer thousands of questions or write thousands of factoids and like research them and check them, all those kinds of things, or read thousands of papers.
Yeah. No, Stack Overflow is another great example of that. And it's just, and those are both two incredibly productive communities that generate a ton of value and capture almost none of it, right? And it's, and in a way, it's almost like it's very counterintuitive that people, that these communities would exist and thrive, and it's really hard to there aren't that many communities like that.
So how do we do that for science? Do you have ideas there? Like what are the biggest problems that you see? You're working on some of them.
Like just on that, there are a couple of really interesting experiments that people are running. An example would be like the polymath projects. So this is kind of a social experiment that was created by Tim Gowers, Fields medalist, and his idea was to try to prove that is it possible to do mathematics in a massively collaborative way on the internet. So he decided to pick a couple of problems and test that. And they found out that it actually is possible for specific types of problems, namely problems that you're able to break down in little pieces and go step by step. You might need, as with open source, you might need people that are just kind of reorganizing the house every once in a while, and then people throw a bunch of ideas, and then you make some progress, then you reorganize, you reframe the problem, and you go step by step. But they were actually able to prove that it is possible to collaborate online and do progress in terms of mathematics. And so I'm confident that there are other avenues that could be explored here.